Hey everyone. In this video, we're going to take a look at how to factor a polynomial by removing the greatest common factor. Okay, so the first step here is to find the greatest common factor between each of the terms in our polynomial. So in our polynomial here, we have two terms, 6x to the third and 12x squared. Okay, so looking at the coefficients 6 and 12, we're looking for first the common factor between those two. We're looking for the greatest number that you can divide both 6 and 12 by. In this case, it's going to be 6. And then we're looking for how many variables they have in common, x to the third and x squared. Okay, we're going to use the smaller of the two, or the less than of the two, which is the x squared, meaning that they each have an x squared in common. All right, after that, what you're doing is you're dividing that greatest common factor by each of the terms in your polynomial. Now, we know the rules for dividing means that you are dividing the coefficients and then subtracting your exponents. Okay, and whatever is left is going to go inside the parentheses. So let's look at the first term here. We're going to be dividing each of these. So 6 divided by 6, that's going to give me 1. And then I subtract my exponents, x to the third minus x squared. That's going to give me x to the first. Okay, so that's my first term. And now I'm going to do the same thing with the second term. So now we're going to do 12 divided by 6. That's going to give me 2. And then I have x squared minus x squared. It's going to give me x to the 0, but I don't really need to write that. So we'll leave that out. And there's our final answer. Okay, so again, this piece out here is your greatest common factor that you removed. And the x plus 2 is the leftover when you divided by that common factor. And again, factoring here is pretty much trying to find the roots. It's almost like you are doing the reverse distributive property. Let's take a look at a couple more examples. Okay, so we have a trinomial here. Same rules though. We're going to look first for our common factor. So I have a 20, a negative 15, and a 10. Those can all be divided by 5. And then I have an x to the fourth, an x squared, and an x to the sixth. So I'm going to again use the least of those, which is the x squared, meaning they all have at least an x squared in common. And now I'm going to use the rules for division to divide by this common factor from each of our terms. So 20 divided by 5, that would give me 4. And then x to the fourth minus x squared is going to give me x squared. Negative 15 divided by 5 is going to give me a negative 3. X squared minus x squared is again x to the 0, so I don't need to write that. 10 divided by 5 is going to give me 2. And then x to the sixth minus x squared is going to give me x to the fourth. And there you have it. Again, GCF, your greatest common factors on the outside, and everything that was left over when we divided is on the inside. Now you'll notice if you have the right answer, you shouldn't have any common factors left inside the parentheses. All right, let's take a look at one more example using multiple variables. Okay, so here we have a binomial, but with multiple variables. Same process though, we're first looking for what we can divide each of our coefficients by. I have 6 and 8, those can both be divided by 2. And now I'm looking at my variables. I have x squared and x to the first. So I would use the x to the first. And I have y to the third and y squared, so I would use the y squared. Okay, so again, there's my greatest common factor. And now we divide to get our parentheses. So 6 divided by 2 is going to give me 3. X squared minus x to the first is just x. Y to the third minus y squared is going to give me y to the first. Now we do the same thing with the second term. 8 divided by 2 is going to give me 4. X minus x is 0. X to the first minus x to the first is 0. And then y squared minus y squared is also 0. So there you have our final answer. Again, greatest common factor on the outside. And whatever is left over when we divide is on the inside of our parentheses.